Section 4.2, more on slope. Okay, so first of all, we have two properties here. Two parallel lines have exactly the same slope. Parallel lines never intersect, and if we know that two lines are parallel, we know they have the same slope. If we know that two lines have the same slope, we know that they are parallel. Okay? Now, perpendicular lines, these are lines that intersect in a right angle. They have slopes that are reciprocals with opposite signs. So what I mean by that is if one of them has slope -7/15, the other one would have slope +15/7. So flip them over and they have opposite signs. Okay? All right, so what we're going to be asked to do is we're going to be given certain conditions, and we are supposed to write our answers. We're supposed to find the equation of the line that fits it, and then we're supposed to give our answer in both slope-intercept and also in general forms. Okay, so let's look at this first problem. We want to find the equation of the line that is parallel to this line, but that passes through this point. So once again, we're going to be using the point-slope form. We have a point to use, and although we are not given the slope, we are given enough information to find the slope. Since we want it to be parallel, this line that we're looking for should have the same slope as this one. Well, this is in y = mx plus b form, so our slope is -4. So since I want them parallel, I'm going to use this slope and this point. Okay, y minus y1, so that's y plus 10, is equal to our slope, which is -4, times x minus x1. x1 is -8, so this is +8. Okay, now we just need to rearrange things so that we end up in both the correct forms. So right here, I'm going to distribute the -4. -4x minus 32. Okay, so I'm going to go into y = mx plus b form first. Okay, so that means I'm going to start off with y plus 10 equals -4x minus 32. And I'm going to move the 10 over to the right. So I'm subtracting 10. And I get y is equal to -4x minus 42. So that is our answer in slope-intercept form. You should double check that you do have the same slope here, and we do. You should also be able to plug in -8 for x, do the calculations, and end up with -10 for y. Okay, so now let's get this into general form. For general form, we need everything on the same side, so I need a 0. And I also want my a to be positive. A is the number in front of x. Right now, my number in front of x is negative. So what I'm going to do is I'm going to move both of these. This is one answer, okay? Let me rewrite it before I mess things up. To get this into general form, what I'm going to do is I'm going to take both of these and move them over to here. So if I add 4x to both sides, I get 4x plus y. Now add 42 to both sides equals 0. So 4x plus y plus 42 equals 0. This is your answer in general form. We have no fractions. It's in the correct order, and our first number is positive, so we're good. Okay, similar problem. I want an equation to the line through the point 2, -3 that is perpendicular to this line. Once again, we are not given a slope, but we are given enough information to find the slope. The slope of this line is 1/5. We want them to be perpendicular, and perpendicular lines have slopes that are reciprocals with opposite signs. So we're going to use m equal to, reciprocal of this is 5, and we make it negative. By using this slope instead of this one, we're going to force the line we're about to calculate to be perpendicular to this line. So let's plug into our point slope formula. Y minus y1, y minus a negative 3 is y plus 3, is equal to the slope, which is negative 5, times x minus our x1, which is 2. Okay, let's distribute the negative 5. Negative 5x plus 10. Okay, now let's subtract 3 from both sides, and we have our answer in slope-intercept form. So I have y is equal to 5x plus 7. This is one of our answers. Now let's take this and transform it into general form. I'm just recopying it right here. And for general form, we want our x to be positive, and we want everything on the same side. So since this is negative, I'm going to move these over to here. Now, if my slope happened to be a positive number, I would just move the y over to the right, and everything would be there more quickly. So I'm adding 5x to both sides, so I have 5x plus y, subtract 7, equals 0. And that's the second version of our answer. Okay, so let's check out this one. I want the line that goes through negative 1, 3, and I want it to be parallel to this line. Now, in the previous two problems, we were given our equation that we wanted to be either parallel or perpendicular to. We were given it in slope-intercept form. Well, we don't have that here, so we're going to need to find the slope, which means we need to solve this thing for y. Okay, so I have 3x minus 2y minus 5 equals 0, and I want the y by itself. So I think what I'm going to do is I'm just going to move this over to this side. So I'm adding 2y to both sides. Okay, now I need to divide everything by a 2. And I'm going to flip the equation around so it's a little bit more standard for us. I have y is equal to 3 halves x minus 5 halves. Okay, so the slope of this line is 3 halves. Since I'm trying to create a parallel line, I'm going to use the same slope. So this is y minus y1, which is 3, is equal to our slope, which is 3 halves, times x minus our x1 is negative 1, so this is x plus 1. Okay, now we need to simplify this. You can kill the fractions at this point, but they're going to come back if you go into, when we go into slope-intercept form. So I suggest just, dealing with it. You have calculators that do fractions, so they should not be too scary. And here I'm distributing and I'm multiplying by the very incredibly hard, difficult number of 1. So 3 halves x plus 3 halves. Okay. Now I'm going to use my calculator to add 3 to 3 halves. So 3 plus 3 over 2 gives me 9 halves. So y is equal to 3 halves x plus 9 halves. Okay, so that's our answer in slope-intercept form. Now we need this to be in general form, so I'm going to recopy this. Okay, and one thing I know is that I'm not allowed to have fractions. So my common denominator here is a 2. I'm going to multiply absolutely everything here by a 2. And that gives me 2y is equal to 3x plus 9. Now we want everything on the same side, and we want our x coefficient to be positive. So that means, since this is already positive, I'm going to move this one over to here this time. So I get 0 is equal to 3x minus 2y plus 9, which is probably better written 3x minus 2y plus 9 is equal to 0. So each of these is your answer. Okay. So one more of these is very similar, except we want to be perpendicular this time instead of parallel. We still need to solve this thing for y. So I'm just going to take, let's move the x over to here and move this over to here. 7y is equal to negative x plus 12. So divide everything by a 7. And we get y is equal to negative 1/7 x plus 12 over 7. So this slope here is negative 1/7. I want them to be perpendicular, so I'm going to use slope of, the reciprocal of this would be 7. This is negative, so this is positive. Okay. Now y minus y1, so y plus 9, is equal to our slope times x minus our x1, which is a 5. Distribute the 7. Have 7x minus 35. Now subtract 9. Y is 7x minus 44. So this is our answer in slope-intercept form. To go into general form, I want everything on the same side. And since my x value is positive, basically I move the y into here by subtracting y from both sides, and I'm going to flip the equation around just like I did before. So this is the same thing as 7x minus y minus 44 is equal to 0. Both of these are our answers.